Good day, students. Let us discuss today about kinetic and potential energy. Okay, so first, let's define first what is energy. Okay, energy is the ability to do work. Okay, everything that happens in the world uses energy. Okay, anything that we do, just like say for example, at this very moment, I am making this video, so therefore, I am using my energy. Okay, most of the time we can't see energy, but it is everywhere around us. Okay, so it is also important to note that energy can never be created nor destroyed. It can only be stored or transferred from one place into another, or it can only be transformed from one form into another form. So this is the statement of the law of conservation of energy. So let me give you an example, a specific example. Okay, let's say for example, the energy coming from the sun, which is known as the solar energy. Okay, so the solar energy could be transformed into electrical energy inside our houses by the use of solar panels. Okay, and that electrical energy will be, or it will become, heat energy. It could be also light energy or sound energy after being used by our appliances at home. So from solar energy, it became electrical energy, and finally it became heat, light, or sound energy. Okay. What are kinetic and potential energy? Okay. So let's discuss first potential energy. Okay, the energy stored in an object. So from the word itself, potential, it simply means that energy has the ability or has the potential to do something later on. Okay, so we have two types of potential energy. We have the gravitational potential energy and we have the elastic potential energy. Okay, so we have here examples of potential energy. Okay, we have a stretched rubber band. Okay, so this is an example of an elastic potential energy. So once you stretch a rubber band, you are making it to have potential energy or store within itself. Okay, so a more stretched rubber band, of course, has more potential energy that once you release it, it can have strong impact because it has more potential energy. Okay, so then next we have water at the top of a waterfall. So this is an example of a gravitational potential energy. Okay, so the higher the location of the water falling down the ground, the greater will its potential energy. So therefore, it could also have greater impact once it reaches the ground because it has more potential energy. Okay, then the third one, we have the yo-yo in your hand. This is an example of a gravitational potential energy. Since the yo-yo will be released downward, so the higher your hand from the ground, the greater will be the stored potential energy of the yo-yo within itself. Okay, then the fourth one is a drawn bow and arrow. So this is an example of an elastic potential energy. Since you will be stretching the band here, so the more you stretch the band, the more potential energy it can have or it can possess. Okay. Factors affecting potential energy. Okay, what are those factors that affect the potential energy of an object? Why are some objects possess more potential energy and why some objects are having less potential energy? So what affects them? Okay, so first, the first factor is the height of an object. So if an object is situated at a higher position, so the higher an object, the more potential energy it has. Okay, then the next factor is the mass of an object. Okay, so if an object is massive, then therefore it has more potential energy. Okay, so we have here an example. Which object has more potential energy? Is it A or B? Is it a brick Okay, so the answer is okay, A, or a brick. Okay, this brick has more mass than the feather, so therefore it has more potential energy. Okay, next example is we have the situations A, B, and C. So, if I want to drop an apple from the top of one of these three things, where will be the most potential energy? Kapag ka ang apple ay ilalagay ko sa bawat tuktok ng mga bagay na yan. Okay, letter A is a skyscraper, and letter B is a chair, and letter C is a crane. So kapag ilagay ko yung apple sa mga tuktok nila, okay, which of them will an apple have the most potential energy? Palagay nyo. Okay, so the answer is, okay, letter A, in a skyscraper. Okay, because the higher the object, the more potential energy it has. Okay, next, potential energy converted to kinetic energy. Okay, so when can we say that the potential energy has already been converted into kinetic energy? So the answer is, it is when an object begins to move. Okay, so just like say for example in our pictures here. So we have here, let's use the pen. Okay, so let's say for example this man. Okay, this man, while the man is standing and not moving, so therefore he has the potential energy in him. But once this man is starting to move, then therefore he is, or his potential energy is now being converted into kinetic energy. Okay. Next, okay, kinetic energy. Okay, so what is kinetic energy? Okay, it is the energy of a moving object. Okay, so all objects that move possess kinetic energy. So from the word itself, kinetic, it means movement. Okay, when stored energy is being used up, it is making things move or happen. Okay, so these are some examples of kinetic energy. So we have the skiing lady, then we have the running big bike, and we have the running man, then we have the sliding boy. Okay, so those are some examples of kinetic energy. Okay, factors affecting kinetic energy. Okay, what are those factors that affect kinetic energy? Why are there some things having more kinetic energy and some are having less kinetic energy? Okay, so one factor is the speed of a moving object. The faster the object moves, the more kinetic energy it has. Okay, then the second factor is the mass of an object. So the more massive an object is, the more kinetic energy it has. Okay, so we have here an example. When these objects move at the same speed, which will have more kinetic energy. Okay, so kung pareho sila ng speed, yung bilis ng kanilang takbo, okay, saan kaya sa kanilang dalawa ang may mas mataas na kinetic energy? Is it a truck or is it a car? Okay, so the answer is a semi-truck has more mass. Okay, a truck is massive, so therefore it has more kinetic energy. Okay, so let's now move on to the problem solving of problems involving kinetic energy. Okay, so we have here the first problem. Okay, a 2-kilogram ball is moving at a velocity of about 5 meters per second. What is its KE? Okay, so always remember that in solving problems mathematically or scientifically, we should always consider or follow the GRESA format. So what is this GRESA stands for? Okay, so GRESA, G stands for the given, R stands for required. E stands for equation, S stands for solution, and A stands for answer. Okay, so first we will identify first what are the given in the problem. Okay, so we have here, okay, so let's use the pen. Okay, so we have here 2 kilograms and we have the 5 meters per second. Okay, so 2 kilograms. So from the word kilogram, kilogram is, as we all know, kilogram is the unit of mass. Okay, kilogram, gram, milligram, pounds, ounces, those are the units of mass. So 2 kilogram is the value of our mass. Okay, the next we have the 5 meters per second. So meter per second. Okay, so meter is the unit of distance. And second is the unit of time. Okay, so just always remember that if the unit is distance over time, it is automatically the unit of velocity or speed. So, pwede siyang meter per second, meter per minute, meter per hour, or pwedeng kilometer per hour, kilometer per minute, kilometer per second. So, those are the units of velocity or speed. Okay, so but sometimes, meron kayong makikitang yung the unit of time dito sa baba ay may nakasulat na squared. Halimbawa yan, meter per second squared. Okay, so kapag ganito, if the unit of time is already being squared, so this is no longer the unit of velocity, but instead, this is already the unit of acceleration. So magkaiba yon. Okay, but in this case, in our problem, since wala naman siyang squared, so therefore this is just the unit of velocity. So 5 meters per second is the value of our velocity. Okay, so we have, okay, so let's erase first this one. Okay, so next, so we already have identified our given. So next will be the required. Okay, so what is being asked in the problem? Anong tinatanong? What value or what quantity is to be solved in this problem? Okay, so ano ba yung tinatanong? Okay, so it is clear here that it is being asked here, what is its KE? So therefore, kinetic energy is being asked. So that is our required. So we have our required is KE. So since KE is being asked, so therefore we will be using the formula of KE as our equation. So we have the formula of KE is kinetic energy is equal to 1/2 times mass times the velocity squared. Okay, so we already have identified the equation of our required. So next will be our solution. Okay. So in our solution, in writing our solution, the first thing that we should write first is the formula or the equation. Kasi dito lang iikot ang ating solution. Ito lang kasi ang ating susundan. We will only have to substitute all the values of the equation. Okay, so we have the formula of kinetic energy is KE is equal to 1/2 times the mass of an object times the velocity of an object squared. Okay, so yan lang ang susundan natin. Okay, next is, okay, so tanggalin muna natin. Okay, next is we have, okay, it is equal to 1/2 times 2 kilograms times 5 meters per second squared. Okay, so 2 kilograms is our, or this is the value of our mass. Then 5 meters per second squared is the value of our velocity. Okay, so yeah, sinubstitute lang natin ang mga values. Okay, the next is, okay, so it is equal to 1/2 times 2 kilograms times 25 meters squared per second squared. Okay, so we have, okay, this is the value of our mass. And saan ba galing itong ating 25 meters squared per second squared? Okay, so since here, the value of our velocity is being squared, okay, so it means that the value of the velocity should be multiplied by itself twice. Okay, so since the value of our velocity here is 5, so 5 times 5 is equal to 25. Okay, then meter times meter is equal to meter squared. Okay, then second times second is equal to second squared. Okay, so tanggalin ulit natin. Okay. Okay, the next we have, okay, it is equal to 1/2 times 50. Okay, so let's use the pen again. Okay, so it is equal to 1/2 times 50 kilograms meter squared per second squared. Okay, saan ba galing ang ating 50 kilograms meter squared per second squared? Okay, so we only have just multiplied the mass of an object times the velocity of the object. Dalawa lang. Okay, so 2 kilograms times 25 meters squared per second squared is equal to 50 kilograms meters squared per second squared. Okay, the next is, okay, it is equal to 50 kilograms meters squared per second squared over 2. Okay, so tanggalin ulit natin. Okay, so we have here. Okay, so how did we get the 50 kilogram meters squared per second squared over 2? Okay, ito. Okay, so it is just from here. Okay, so dito. This is understood as over 1. Okay, so let's just do the operation. Okay, so 1 times 50 kilograms meters squared per second squared is equal to 50 kilograms meters squared per second squared. Okay, then next is 2 multiplied by 1. Okay, so 2 times 1 is equal to 2. So ito yun. Okay, so the answer is, it is equal to 25 kilograms meter squared per second squared. Okay, because we have 50, okay, this one, 50 kilograms meter squared per second squared divided by 2 is equal to 25 kilograms meter squared per second squared. Okay, so the answer is, or the final answer is 25 joules. Okay, why joule? Okay, bakit joule? Okay, so joule is the unit of energy. Okay, always remember that 1 joule is always equal to 1 kilogram meter squared per second squared. Okay, so here in our problem, the 2 kilogram ball, which has a velocity of 5 meters per second, has a kinetic energy of 25 joules. Okay, so that is an example of how to solve problems involving kinetic energy. Okay, next, let's solve problems involving potential energy. Okay, so we have here the first problem. Okay, what is the potential energy of a 3 kilogram book on top of the table, which is about 1.5 meters height. Okay, so following again the GRESA, we have, okay, so let's identify first the given. What are the given in the problem? Okay, so we have here 3 kilograms and we have the 1.5 meters, which is the height. Okay, so first 3 kilograms. Okay, so when we say kilograms, so of course this is the unit of mass. So 3 kilogram is the value of our mass. Okay, tanggalin ulit natin. Okay, then since, okay, so next is 1.5 meters. So meter is the unit of distance or height. So 1.5 meters is the value of our height. Okay, so we already have identified our given. The next will be the required. Okay, what is being asked in the problem? Ano yung hinahanap? Ano yung tinatanong? Okay, so it is clear here. What is the potential energy? Okay, so potential energy is being asked. So potential energy is our required. So PE is unknown. Okay, so we already have identified our required. The next will be the equation. Okay, so since P is being asked, or the potential energy, then therefore we will use the formula of potential energy, okay, as our equation, or in our equation. Okay, so the formula of potential energy is PE is equal to mgh. M stands for mass, G stands for, okay, G stands for acceleration, okay, due to gravity, which is always equal to 9.8 meters per, okay, so G stands for acceleration due to gravity, which is always equal to 9.8 meters per second squared. Okay, so G, or acceleration due to gravity, its value is constant. So, ibig sabihin, kahit saan tayo pupunta dito lang sa Earth, our acceleration due to gravity is always 9.8 meters per second. Hindi yan pwedeng baguhin. Yan na talaga yon. Okay, so always remember that, huwag niyong kalimutan, just always remember, kahit saan kayo pupunta, kung kayo ay tatanungin, what is the value of our G? So, you should always answer with 9.8 meters per second squared. Okay, so we have the formula of our potential energy is PE is equal to the mass of an object times the acceleration due to gravity times the height of the object. Okay, the next is, itanggalin muna natin ito lahat. So we already have identified our equation. The next is our solution. Okay, so again, so we will start our solution by writing the formula of the required. Okay, so PE is equal to mgh, or mass times acceleration due to gravity times the height of the object. Okay, so we will only have to substitute the values. Okay, so we have here, okay, potential energy is equal to 3 kilograms, which is the value of our mass. The 9.8 meters per second, so may squared pa yan dito, per second squared is the value of our acceleration due to gravity, and 1.5 meters is the value of our height. Okay, the next is Okay, so the answer is it is equal to 44.1 kilograms meters squared per second squared. Or the final answer is, okay, potential energy is equal to 44.1 joules. Okay, so I hope you learned something and you enjoy learning. Good luck.